Hello students and welcome back to Mechanical Engineering Practice and Graphics. Today I will be covering the chapter 14 of the book, Working with Drawing Views. So we are in week 12 of the semester. We already had the quiz number 4 last Monday, and this week we have two more submissions. We have the fifth part of the final project and also the homework number 9. For next week, we will not have any quiz or any part submission. You will finish the final project parts this week. However, we will have one last homework. Um, there are some important upcoming dates. In week 14, the week from November 23 to November 27, that Monday and that Wednesday, we're going to have the final project presentations. So you will be presenting either your PowerPoint slides or you are going to be presenting your poster. And then we will have the final exam in the last week of classes, which is week 15. That is the week from November 30 to December 4. So we still have a couple of weeks there. That will be a final exam of the lab, and you will be submitting also the full package of your project to Blackboard. So as I just mentioned, this week we have the fifth part submission for the final project. This will be your last part submission to Blackboard. Okay. So this week I'm going to do the homework with you, which means that for you to do your homework, you just have to follow this tutorial. We're gonna do a blueprint directly in SolidWorks. And for that, we're gonna use one of the provided parts that we use earlier in the semester. So these are the instructions for the homework 9. We will use the vice body part, which you already saw in a previous video tutorial. And the objective is to do the blueprint of the part, including all the geometric information and technical information of the blueprint. So you will have to have in the same folder, you'll have the SolidWorks part file with this SLDPRT file extension. You will also have the SolidWorks drawing file of the part, which will have this file extension. And also I will show you how to save that as a PDF. Then we're gonna compress the folder into either a zip file extension or RAR file extension. And then you will submit the compressed folder to Blackboard. Now it is important that you have the SolidWorks parts file within the same folder than the SolidWorks drawing, because what the SolidWorks drawing is gonna do is gonna go to this file and refer to the geometry in that file in order to represent the drawing. So that's why we have to have both within the same folder. Now, the SolidWorks drawing file, you can save it and then modify it later if you need to. However, the PDF file will not allow you to do so. Once you have the PDF file, that file cannot be modified, at least in SolidWorks. The same rules apply for this homework. It's gonna be due next Sunday at midnight, and you have to submit the compressed folder using the correct file naming convention that we've been using throughout the semester. So this is the geometry that I provided to you. It is already in Blackboard, and I'm gonna show you how to download that one. And this is the blueprint that I'm requesting from you. So in the blueprint you will have 3 technical views: top, front, and right. We're gonna have a detailed view of whatever component in the blueprint. And also we're gonna have a section view. These are the main types of views that you're gonna be using as mechanical engineers, as professionals. And the technical information is, for example, the material of the part, who modeled it, the date, who revised, and the name of the part, which is gonna be marked here in the lower table of the blueprint. So we're gonna go to Blackboard, we're gonna log in. Okay, and once you are in Blackboard, we're gonna go to the content of the course. Then to our folder, week 12. And here is the link for the slides and for the SolidWorks part file. Here we just click in these three dots, download. And I'm gonna put it week 12. I'm gonna create a folder that is gonna be lecture 2 or lecture 3, depending on in which one you are. My ABC123, which is LJK354, and then homework 9. And in that folder I'm gonna save the vice body part. Now I can go to SolidWorks and I'm gonna create a new drawing. This time we're gonna be using the drawing module. Here we have a first window that is asking us which format do we want to use. There are some standard formats. In our case, we're gonna use A2. Now this A0, A1, A2, A3, they mean the size of the format. As you see, as the number increases, the format gets smaller and smaller, and the lower the A value, the format is larger. In this case, we're gonna use the format A2. We click OK, and then we can look for the part that we want to import. Vice body. So by default, it is putting the front view. I'm gonna place it somewhere around here, and then I can move to create the right view, and also I can move the mouse upwards to create the top view. And here I can create this isometric view, and then I can click here in OK. Now for the isometric view, I'm gonna move it maybe up here, and then I want to show the shaded with edges, this one. Okay. Now in that part that I provide to you, we have this invisible material. We can change that material by opening the part. And in this part, I'm gonna change this to this representation. I'm gonna change the appearance of this part. gonna use I'm gonna use a plastic. Oh no, maybe just a printed this red one will do. Yeah. Okay, and then I can save this part as it is, and then I can open the blueprint, and automatically the appearance has changed. Okay. As you see, when I click one view and move it, they try to remain in a straight line from the center view. I can also move the top view up and down, or the right view left and right. Okay, now usually we try to make the blueprints using these hidden lines, and then we can see any hidden hole. For example, these holes in the bottom are gonna be hidden in the top view. So we can use the center mark to define the center of those circles. This one already has it. And then we can also use the center line for those cylinders. This cylinder here comes from this circle on the right view, and also on the top view we have the same. It's coming from this one. Okay. So we have all of those center lines. I forgot the ones here in the right view. We can just make them real quick. So here on the top of the annotation module we have center mark and center line. Okay, here we have view layout, annotation. We can also do some sketches here. We can evaluate geometries and see if something is wrong. We can do renders here as well. Okay. Now to create a section view, for example, the one that I have here on the right, we have to create this line that represents where the section or where the material is being cut in order to represent that section. So we go to view layout, create section view, and here we have different directions for the sections. I'm gonna select a vertical line, and then I'm gonna place it here in the center point of this line, and then I will move that section here to the right. And as you see, this section is representing what portion of the material is being cut when I cut along this line. Now to do detailed views, we can use here in the view layout, we have this other button that is called detailed view. And we can draw a circle of the detail that we want to highlight. So for example, I'm gonna highlight this portion here, and I can place that detailed view. In the example, I'm putting it directly below, so that's what we're gonna do. Right there. Okay. Remember that I'm working on millimeters, gram, and second, and I am using 1:1 scale ratio. So here in the view layout, we have a couple of buttons. The standard three views, which are front, top, and right. We can have also a model view that we already have here. We can project views or auxiliary views. For example, from this view, I can have this auxiliary view here. But in this case, I don't need it, so this is just to show you that you can do that. And then here in the annotation, the most important controls are the Smart Dimension tool to define dimensions of the model. We have a couple of surface finish options, geometric tolerances, plane tolerances, and so on. We'll be using the balloon callout in the next week's class. You can also define tables. For example, in previous assignments, I have provided a table with the list of parts to do an assembly. You can do also the blueprint of an assembly. Okay, now let's click here in the Smart Dimension tool, and we're gonna start defining some dimensions. Now, I'm gonna zoom in here and show you that, as you can see, these are my three main views, and between those views, I mean in this space that I'm highlighting here with the mouse, between the front and the top view, I don't have any measure, any dimension. Neither do I between the right view and the center and the front view, sorry. And that's because usually we try to leave that space clean and empty. Okay? So the idea of this assignment is for you to get familiar with the drawing module. We just have to draw all of these dimensions that I have highlighted in this blueprint example and submit that to Blackboard. So let's start. I'm going to start with the ones here on the left. I can click this line and then this line. And then I have this yellow half of circle or this other at the right side. It's by default, it can place the dimension in any of those 2 points, or I can just move it around. But I just rather use that default control. Then we have this line. Remember that you can modify the dimensions here. You can add, for example, tolerances if you want. This is just one quick example on how you can add a tolerance for this dimension in a blueprint. We can change the type of the arrow if you want a different kind of dimension there. They all mean the same, so I will just stick with the default arrow. You can use different kind of lines. You can even use break lines. And there are a few other controls here that you should explore. You can change the font of the document as well. So yeah, you have a lot of control on how you present these dimensions in the blueprint. Okay, I'm going to continue adding dimensions here. And then I have this line. I can reduce the number of decimal positions for a given dimension. I'm just showing you that you can do that, or you can also have basic tolerances here. But in this case, I'm not gonna include any of those tolerances. This then can go here. Then we have this 22. Now since this 22 is being overridden or on top of this arrow, I'm just gonna move a little bit lower, and that's fine. In the ideal case, we should avoid any a, a point where two dimensions are crossing. So I can either have this 22 here, or I can move it upwards. But since I'm just representing the same as I did in this example, I'm gonna just leave it there. Okay, then we have this dimension. Like that. Then we have a 27 here. Sorry, a 7. Actually, I'm gonna delete that one. And I'm gonna use the automatic option. As you see, when I move one dimension uh, over, it shows me like a yellow discontinuous line guiding that all the dimensions should be at the same level. Or we can have multiple levels as I'm doing here in the bottom. Then we have this 36. And we also have this 52. Maybe I should move this section a little bit to the right. And then we have in the top, we have the outer radius and the inner radius. Sorry, the inner diameter. So this one goes here. And this one goes there. And then we have the center position of the circle, which is 32. So to select the center, I can just select first the side and then this vertical line of the center position of the circle. And then I'll have it there. And then in the section we have this 50 degrees angle and this chamfer. So I select the two lines and then this quarter of circle in the top. and then I can select this fillet here. Now this one, there are two of those, so I have to define 2x, and that's it. Now we're gonna focus on this detail view. The first thing is this angle here. Then we have this distance and also the diameter. Now this diameter, there are 4 of those holes like that. So I'm gonna move that one here. And those 4 holes are gonna be these 4 holes that we have on the top view. Now it is time to modify the top view at those dimensions there. I'm gonna do the same for this one. And then this 44. That one is fine. And then we have the horizontal position of those. And that's it. We have all the dimensions that we need. We can move all of this to a side, make it more a better distribution. Now in the isometric view, we never add any dimension there. Maybe just quick notes, but we avoid any dimension in the isometric view. The isometric view should be clean, and it's meant only for general understanding of the geometry of what you're representing in the other views. Now here we have a different a bunch of boxes that we can fill. In this case, the title is cast iron, and the drawing number is device body. Here we have the size of the sheet or the format. Now we can right click there and then select edit sheet format. We can add values here. So for example, in the name of the drawing, you can place your own ABC123. But usually the technical letter is in uppercase, so ABC123. And then since I'm gonna be rating this, I am the one who approves this. So for example, LJK354. Here we can have the material. We can add a note here. I don't know, ABS, for example, if this is 3D printed. On the date, we can place today's date is 11/11/20, and then this is due on the 15th, so 11, 15, 20. Here you can add your signature if that is the case. Yeah, so you can add all of this information there. In the example I was using, let's see, yeah, just the same, the date, who is drawing it, who is approving it, and the name of the part. So I would like you to always try to fill these spaces. It's a good practice because this is useful information when you're actually doing blueprints in your place of work. Once we have finished this, we can just exit this edit mode, and we have our first blueprint of the semester ready. So you can save this blueprint, and I'm gonna show you. You just click here in Save As, and as you see in the Save As type, we have drawing. The file extension is SLDDRW. You can keep the vice body name, that's fine. And then I can close this file, and actually I'm gonna show you that file. That file is here in the slides, week 12, in the homework. See that I have the SolidWorks part file and also the SolidWorks drawing file. Now in SolidWorks, we can just take a screenshot of this and paste it in a PDF. But the better way of doing this is just you click here in Save As, and this time we change the file extension to Adobe Portable Document Format, PDF. And we can keep the same name if we want. Now it will create this PDF. I'm gonna show you here a PDF file, and then this is how the PDF looks like. Okay, now I can close my PDF viewer. I can close SolidWorks because I already saved everything. This one I can also close it. Then I will go back to my previous folder, and then here I'm gonna right click on that folder and then click in Add to L2-LJK354 homework9.rar. This is the compressed folder that I will submit to Blackboard. So I just go to Blackboard and submit this file. Okay, that's all the tutorial for this week. I think it's a very easy homework for you. You just have to follow the same steps that I just did in this video tutorial. Remember that we have to submit the 5th part this week. Next week we only have the last homework. And then we have the final project presentations and the final exam. Thank you very much for watching this video, and stay safe.